Synthesizers.com oscillator. We have a cable plugged in, the Exponential Frequency volt per octave input, which basically I am controlling it from a keyboard. The output is going into a Synthesizers.com VCA module as controlled by the keyboard's gate, which is controlling a Synthesizers.com envelope module. So that's the sound you'll be hearing. This is what the Synthesizers.com oscillator sounds like on the sine wave setting. I've just changed the range so that you could hear all of the octaves that it is capable of. I started at the lowest, which is 32 foot, and then played the subsequent octaves up until we got to 2 feet, which basically goes up and right out of the audio range, which is very cool. Let's hear the triangle waveform. And now the saw waveform. And the pulse wave. Frequency knob. This is fine control of the frequency instead of octave control of the frequency. Next we have the linear frequency, which is basically the input for frequency modulation. I'm going to be using this oscillator, which is the same as this oscillator, as a low frequency oscillator to control the frequency of our main oscillator here. First of all, let's take a sine wave output and we'll put that right into the linear frequency input. I have it on a low setting. Of course, controlling the frequency of the low frequency oscillator will change the frequency of our main oscillator. And of course we can get some pretty serious frequency modulation effects when we make this modulation more than low frequency, but rather high frequency modulation, high frequency oscillation. And of course we can just have it as something as simple as vibrato. And we don't have to stop at the sine wave, we can also do things like the saw. The ramp, now we'll get to see why the ramp is beneficial. And of course the pulse, the square wave, which is what we have it set for. And of course, using the oscillator as a low frequency oscillator, we can control the width of that pulse wave, and here's your first chance to see what that can do. And that is basically what linear frequency is for. We can also, if we want, use an envelope generator to affect the linear frequency. let's move on to pulse width, which is changing the width of the square wave. I'm plugging the pulse width into the sine output of the other oscillator so we can hear what effect that will have. Okay, we're still on the pulse, so let's hear that pulse again. Here's us changing the shape of the square wave, basically making it into a rectangle wave, which is a pulse wave. And as the up portion of that square wave, the part we call the square wave, gets thinner and thinner, you get a more and more nasal sound. Until we've made it so thin that actually no waveform exists. And that will happen in both directions. So you can either have what's called a pulse wave, which is a very narrow square wave. You can have a full square wave. Or you can vary the width of the wave by moving this knob. More easily done and more satisfying is to allow another oscillator to control the width of the wave for you. In this case, we're going to be using a low frequency oscillator. As I turn this up, you will hear the effect. You can hear the point where the waveform is actually causing the square wave to become too narrow to be heard. So you'll want to find a setting where that doesn't happen, unless that's an effect you want. Not only can we use of course, the oscillator to affect the pulse width, we can also use an envelope. So that's very effective and creates a great variety of sound. Next, we have exponential frequency, which is usually used, or, well, depending on what you do, but it's usually used as the control voltage from the keyboard to control the pitch or frequency of the oscillator. But in addition to that, we can also do fun things like control it with the waveform put out by a low frequency oscillator. Having a modulation input on the exponential frequency has a much greater effect than using the linear frequency. Let's use the level controlled one so we can see the difference. So basically, it will go for the whole frequency of the oscillator, starting at the lowest possible pitch, going up to the highest possible pitch within the audio range. You can hear just clicks there. So you can get a lot of different effects with that. Pulse wave, and I'm altering the width of the pulse wave to affect the frequency of this oscillator and the frequency of the square wave, pulse wave that is affecting the frequency of this oscillator. controlling the level here controls the amount of pitch change that is happening in this oscillator, which essentially controls the hard sync effect. That is essentially the Synthesizers.com oscillator. Of course, many, many more things can be done with it. This is just a sort of basic outline of its functionality and sound. Thank you.